Everyone, welcome back to Code to Serve Academy. Today we are going to start chapter 3, that is user defined method. Okay, so let us see what is function or method. A method or a function is a sequence of statement that carries out a specific task. What does it mean? If I tell you to write your name 100 times, then what you are going to do? You are going to write that statement 100 times. Similarly, if I tell you like I have to write different lines 100 times. Okay, I want you to write your name, your parents' name, then your relative names, like that, in a sequence of code. Got it? So if you want to write any sequence of code and you want to group them into one particular block, that becomes a function. So we can wrap that piece of a code into a function. Okay, so I will give you an example. Suppose you are given to find the cube of any number. So what we can do, we can write like this. Suppose I'm just writing the part of it. Int a is suppose 10, and if I tell you to find the cube of that number, you will say int result is equals to a into a into a into a. Got it? Now you think of, if I tell you to write the same piece of code 10 times. So if you will write the same thing 10 times, then you have to write total 10 into 2, that is 20 lines of code. Got my point? But if you group them, if you group it into a function and if you call it 10 times, then you will be only writing 10 line of code, and this 2 lines of code will be inside a block. That we call it as a function. We can separate it out as a function. We'll see how to declare a function, what is function definition, okay, what is function signature, all those things we are going to see in the later section. Okay, so let's see next. So why we use method? So this is very important question. Like, what is the need of method? We can directly write the piece of a code. Then what is the use of method? Suppose if you are writing 100 lines of code, then if I tell you in between to write a code to reverse a number, and after that I tell you to write a program to print the Fibonacci series. Similarly, if I tell you to write 10 different logic, so your program will gradually grow into a big program. To separate it out, what we can do, we can create a function. That means you have already learned about, or you already know what is divide and conquer. Like bigger part you can divide into smaller part, and then you can use that smaller chunk in your program. What I mean by this, suppose if you have a bigger program, so this is your task, and this task you have to accomplish. Okay, so what you are going to do, you are going to divide this into a piece of code. Suppose this is function 1. Similarly, you again going to divide this into piece of another code, that is function 2. Similarly, you are going to divide into another piece of code, that is function 3. So all the thing that we have to do, we are dividing into small piece of code, that we call it as a function. Okay, so what is the benefit of this? Suppose here you are writing for Fibonacci series, here you are writing for palindrome number, here you are writing for suppose a SPI number. So in one go, if you write all the code in one go, it will become very much complicated. Instead, what you will do, you will create a function for a SPI number, you will create another function for palindrome number, you will create another function for any other part of the code that you are asked. Okay, so this will reduce the complexity. So you see here, the first point is to cope up with complexity. That means when the program grow big and big, that time if you separate the logic out into functions, so later on when you revisit that program, or you revisit and recheck that program, it will be very easy to understand what is happening. Like here, I will say like palindrome. I am just calling palindrome. Got it? So this is one function call. Here I am calling spy. Okay, and similarly, so when you see this, you will get an idea. So whole palindrome logic is written over here, 10-15 line is written here, spy number logic is written over here, similarly other things are written over here. So what this is happening here, you are able to see, we are able to easily identify that this logic is for palindrome, this logic is for spy number. So that is why we use method to cope up with the complexity. So generally, whenever you make a big project, suppose tomorrow you are given a task to build Flipkart application. So you see that Flipkart application is a very huge application. So you cannot write whole code in one go, in one file. You have to separate it out. Like for the home page, you have to write a separate code base. For login page, you have to write a separate code base. For sign up, you have to write a separate code base. Because why we are writing like this? Because tomorrow, if any problem is happening in the login page, you will not go and find the error in the complete code. You will only go to that part and you will try to find out the error in only that particular portion. Got my point? So that is the beauty. Like when the complexity grow, that time it will be very beneficial for you all. Okay. Next, to hide the low level logic. Suppose tomorrow, like when you see, like suppose we were reading about like in the first chapter, like when we are dealing in the class 9, like we are hiding the unnecessary detail and we are only showing the user the detail that is required for them. What I mean by this, suppose when you are seeing a phone call, you see two buttons. One is a pickup or second one is a end one. But when you click on green icon, that is a pickup, so there is n number of operation is happening inside that, but we are not showing the user what is happening inside that. Got it? Similarly, when you see a calculator, you are using a calculator, so when you click on multiply or you click on into or whatever thing you do, you are not showing the user what is happening inside that. You are only getting the result what you require. Similarly, suppose you write one function, you wrote one function for a palindrome number, you wrote one function. Now what the other end user is going to do, end user is just going to call that palindrome. Okay, that end user is going to call that, and here they are going to pass one number. So here it's your business to write the complete piece of code. So you are writing all this piece of code, but the user who doesn't know coding, who doesn't know anything, they will just call this method. They will just call this method, or to the user you will give a box to enter a number. Suppose you gave them a number to enter, they entered 34. So when they entered 34, they are just entering this number and they are getting the result whether it's a palindrome number or not. But the actual logic you are writing over here. Got my point? So here what we are doing, we are hiding the logic. We are not showing the user what we have written inside this, but we are showing only a box to enter one number and click on check. So one button is there, check. So when they click on check, they get the result whether the number is a palindrome number or not. They are not interested in the logic. They are not interested in the logic, how we are checking whether a number is a palindrome or not. Only they are interested, they give a number and they should get output. If they get the output as true, that is a palindrome, that means whatever logic you have written, that satisfies that number. Got my point? So the second point here is to hide the low level design details, like whatever logic, internal logic was there, we are hiding that. We are not showing to the user, those who doesn't know coding or whatever stuff, the end user who is going to use your application. Like we are using Flipkart, but we don't know how Flipkart is built, but still we are using Flipkart. Similarly, the engineers who have made Flipkart has written n number of piece of a code. Got it? But we are only using, or we are only interested in what we require, right? We are not interested in the internal part. That is what we are not seeing actual implementation. Got it? Next, to reuse the portion of a code. Suppose that I already mentioned, I tell you to find the palindrome number 10 times. Here you wrote palindrome, here you wrote spy. Suppose I tell you to find the Fibonacci series, and then again I tell you to find palindrome. So you are not going to write again 10 line of code. You are just going to call this function again. So here you will write palindrome again. Got it? So to this helps us in achieving reusability. That means a particular piece of code we can use again and again. Got my point? So this is the use of method. Okay, let's see next. The general form of method definition. So I have already discussed this in chapter 2, but still I'm again covering here. Like first, whenever you write the method definition, so there are some part that you should know. First part is access specifier. You have already learned about the access specifier that are public, private, protected. Got it? And similarly, modifiers. So modifier is beyond your syllabus, that it is not in your syllabus right now. But I will tell you what are the few modifiers that you should know. Next is the return type. I have already mentioned the return type means whenever you call this method, whenever you call any function, what is the value that function is going to return. When the execution of that function will end, what the value is going to get returned from that function, that we need to specify. If it is going to return any integer value, then we have to write int. If it is going to return any boolean value, then we have to write boolean. If it is going to return nothing, then we are going to write void. Got it? Void. So this is what return type. Next is the method name. So method name, whatever name we are going to give to a method, like you have to check whether a number is palindrome number or not. So you will write check palindrome or check spy or whatever function you can write. Okay, function name you can write. There is some set of rules like how we were writing a rules, how we were writing a class name or the identifier's name. Similarly, here also we generally use the function name as starting with a small letter, like spy number, check spy. So starting with a small, check spy. But in case of a class name, what we were writing, we were starting with a capital letter. These all are convention. It is not like if you write in a capital letter, it will be incorrect. It is correct, but it is a convention, like we start function with a small cap. Okay. So we'll see what all things, how we need to write the method name, or what all values we can write in the return type, and what is available in access specifier. We are going to see next. Then after this comes the parameter list. Parameter list means, suppose you are creating one function, then in that function, what input you are taking. Suppose you are taking only one number as input, so in the parameter list, there will be only one value. If you are taking two parameters, then there will be two values. So you have to write with the data type. Suppose I want to take two number, then it will be int a, comma, int b. So this will be the parameter list. Okay. Next, after this, we write the curly braces. That is the body of the method, and whatever logic we are going to write, we are going to write inside this body. Okay. Next, so I've already discussed about this. So access specifier are the keyword that defines the accessibility or the visibility of the method within the class. That I've already mentioned in the previous chapter, that it is a visibility, that it is a basically the visibility. Okay. So here we can see, like, it is what are the access specifier available to us: public, private, protected, and default. If we write nothing, that means it is a default. Okay. So if you want to learn deeper about this, so you can go and check the video of class chapter 2. In that we have covered that this topic in depth. Okay. Next, second one is a modifier. So modifier also we can write in the function definition. Okay. And it is a keyword, like it is also a keyword. This all what we are seeing, it is a keyword that we can use within the method definition to alter its behavior or control its accessibility. So out of this, like native, final, transit, synchronized, and volatile, out of this you have already learned about final. I think if you have not covered about final, generally this is beyond your scope, but final generally means what? You cannot change the value. Once declared, you cannot change it. That means you cannot change later. Cannot change. Okay. So these all are beyond your topic. Okay. Syllabus. Just you need to know these all are available inside modifiers. Okay. Next, return type. I already told you like what the function is going to return. That data type we have to specify in the method definition. Okay, so it can be integer, boolean, or any data type that we are returning. It can either be the reference data type, that is an object or a class. Okay, arrays, these all can also be a return type. So return type also will be covering later in depth. Next, method name. What I was telling you, it should be a valid Java identifier. Like I have already mentioned, what is a valid identifier? We cannot start with number. We cannot start with number. So we cannot start with number, and we can start with dollar or underscore. Okay, we can start with dollar underscore. We cannot start with number. We can start with any character. That is any character. Okay. Next, apart from these are the convention. What I already told you, these are the convention. Okay, it should be a meaningful, right? Whatever function you are writing, suppose you are trying to find the palindrome number, so you cannot write PA or you cannot write PL, so you should write palindrome. So if we write like this, it will give other user like what logic we are trying to write inside that function. Okay, so end user or the other user will get the idea what that method means. Next, it should begin with a lowercase. That only I was mentioning before. Like the convention is like function name should start with a lowercase. It is not mandatory, again I am telling, but it is a convention you should follow. Got it? For names having multiple words, like you can use camel case or you can use underscore to combine the two words. Okay? The method name should generally begin with a verb followed by one or more nouns. So these are the convention you should keep in mind. Okay. Next, parameter list. What I was mentioning, like in this function, you see maximum. So if I tell you, you have two number, 5 and 10. So out of this, if I tell you what is the maximum value, either 5 is the bigger number or 10 is the bigger number. So you will say, obviously you will say 10. Similarly, if I want to write in a function, in a method, okay, if I give user a choice to write the first number and the second number, okay. So, and user clicks on check, okay, this button. So if user enters 10, here enters 15, so output should be 15. So if this is the requirement, like user has two input, like they give 10 and 15, out of that you have to tell which one is the maximum. So you cannot tell directly like the first number can be maximum. If user enters here 15, then the first number is a maximum. If user enters in the second box, that means that is the maximum. So you have to write a logic that will check whether the first number is a bigger number or the second number is a bigger number. Accordingly, you will give the output like which one is a bigger number. Got my point? So in this, here we have made one function that is a maximum. Okay. So here, if you see, maximum is a function. We'll cover about this definition. First, you see over here, we have a function name. This is a function name and an identifier. Function name, I told you, start with a small cap, small letter. Okay, it's starting with M as the small. And here we get two parameter. This is the parameter list, what I was mentioning about. Means in that function, whenever we call that function, we get some input to that function. We give some input to that function. So in this function, we are getting two input, that is int A and int B. This means for this function, this A and B is only available inside this block. It is available inside this block. Outside that block, A and B is not available. Got my point? That means in this block, we have a variable A, and in this block itself, we have a variable B. So whatever function, like I want to call that maximum, like I want to call that maximum. Suppose I am calling this maximum function. So I will write maximum, and here I will write 10 comma 15. So user clicks on this check button. I pass the first parameter, pass the second parameter. Got my point? Suppose the second time user pass 15 comma 10. So first time in place of A, 10 will come, and in place of B, 15 will come. And in the second call, 10, 15 will be here and 10 will be here. Got my point? So accordingly, we are checking whether if A is greater than B, then the answer is A, else the answer is B. So whatever the maximum value is coming, that is getting returned from this function. And if you do over here SOPLN, so we'll get the output as a maximum. Which one is the maximum number? Got my point? So this is how we are going to see how we call a function. This is the function definition, how we define a function, how we write the logic, and this is how we call the function. So we are going to cover it in depth in later section. So for now, for this slide, parameter list is important. Like to a function, whenever we call a function, we get that method gets some input. So that input is basically the parameter list. It can be a one number, it can be a two number, it can be of any length. Okay. Next is, in order to exist, now this is very important. Like in a Java program, whatever program you write, in a single file, there can be n number of classes. Like if I write class 1, class ABC, ABC. Okay. Again, beneath that, I can write class XYZ. Again, beneath that, I can write beneath this, if I want to write, suppose, class PQ. Okay. So you see, within one file, there is n number of classes written over here. So a file in a particular Java program, there can be n number of classes. Similarly, method can only exist within the class. So this is very important. Method can exist only within the class, not outside the class. I cannot write class here, function over here. So function should exist within, must exist, or I should say function only exists within the class, not outside the class. So this is very important that you have to keep in mind. So whatever function we are declaring, like for a palindrome, so palindrome, suppose public static boolean pal int a. So this is the palindrome logic we have written. So it must be present inside any class. It cannot be outside the class. If I rub this, so this is not valid. Okay. So outside the class, this is not valid. Function should exist only inside the class. Got it? That is the point written over here. A Java program can have multiple classes, many classes. A single program can have multiple classes, many classes, but each classes can have several methods. So inside that only, inside any particular class, we can have again several methods. Here is one method inside the particular class. And similarly, we can have n number of methods. So one method is here. We again beneath this, we can write another method, another method. So in a class, we can write n number of methods. Got my point? Next. Now, what is a function prototype? So there is two words that is very important. Function prototype and function signature. Function prototype and function signature. This is two words that will generally come throughout your life. Okay. So how you can understand what is function signature and function prototype. Prototype means just focus over here. Prototype means the complete part of the function definition, part of a function definition, including the return type and the parameter list. You have to keep in mind, prototype means return type along with the parameter list. This is the parameter list, and along with the return type, if we write, then this becomes prototype. And the next topic we have is function signature. Function signature is like the name, whatever name we are writing and including the parameter list. This makes signature. Function signature. And this part we are telling the complete, including the return type. Here you can see I have not included the return type. So this portion we call it as a function signature, and this portion including the return type we call it as a function prototype. Function prototype. Got my point? So these are the two words that you should generally know. Function prototype means the part of a function definition, including the return type and the parameter list. And for function signature, we have to say the parameter list. Okay, the number of parameter and the parameter list. So that is only written over here. You can pause the video and have a look. Like the function refers to the number and the type of arguments. How many types of arguments we have. Next. So a program to understand the proper usage of a method and a function. So here you have to focus like one class is written. The class name is demo method. Got it? And inside that class, we have one function. Inside that class, we have one function. That function is a public void demo method test. Got it? Now you see over here. Now you see over here. Like here is int x, int y, and now we are calling the static function. What we are doing? We are calling the static function. So I have already told you, like whenever we declare a static, in a function, we don't need to create the object of that class. I've already told you in chapter 2. Like, what is the other way? Like if we create another class, public class test. So we created another class. Now I need to call this from any other class. From any other class, if you want to call this. So from any other class, we want to call this. So there is two ways. If that there in the function definition, if static does not exist, focus over here. If the function in the function definition, if static does not exist, then we need to create object. Like here in static exists, then without creating the object, we can we can call this method. But for this case, we don't see static. That means to call this method outside this class, we need to create an object of this class. Got my point? So here you will see, if I want to call this method, outside of that class, then I have to check one thing, whether static is written over here. If static is written, like in this case, static is written, then I don't need to create the object of this class. If static is not written, then I need to create an object of this class. Got my point? This is mandatory. You have to check. Like I want to call this method. So what I will do, I will say demo method m is equals to new demo method. So this is how we create an object. This is how we are creating an object. We created one object, demo method m is equals to new demo method. That is for this class, we created one object. Now, if we want to call this method, we can only call using the object. I told you, like if static is not available over here, then we can only call this method using the object. So if you want to call this method, we'll write m dot demo method test, m dot demo method test. Got my point? So to call this method, we have to create an object. Now you see a logic over here. You see over here, like here static is written. That means we don't need to use this object. Directly we can call this. How we can directly call this? We have to use class name dot method name. So here we have demo method dot demo method. So we are going to call this one maximum. So we'll say class name dot maximum. Okay, and here we'll pass 10 comma 15. So you see over here, there is two separate logic that you have to keep in mind. One is like this method we can only call by creating a method or object, and this method we can directly call it without creating a method. Got it? Why? Because in this method we have declared static, That is why whichever method is in whichever method there is a static written, that means you can directly use the class name dot the method name. Class name dot method name. If static does not exist, then you have to create first, you have to create object. Then using that object, you can call this method. Using that object, you can call this method. So this is what you have to keep in mind. Okay. Next. Next is the use of a void. I have already told you, like void is like the function will not return anything. If the function is not returning anything, then we use void. So we write void, then the method name, and then the parameter list. Okay. Next, so accessing a method or a function. So if suppose a function definition is like we have to find an area like float area. So float area, we have two parameter. To find an area, we require length and breadth, A and B, L or B. Okay. So if this is the definition, function definition, okay, float area, then we write float something is written like L. Suppose here it is float L and float B. There is two parameter that we need to pass to this function. Okay. So how we are going to call this? How we are going to call this? To call this method, we are going to write the function name. We are going to write the function name. What is the name of the function? Name of the function is area. Then we are going to write the parenthesis, and in that parenthesis we are going to write the parameter list. Suppose this function is having two parameter list, so here we will write two parameter. Like in the function call, we are going to write two parameter. Got my point? So we are going to pass x comma y. That means this x will get assigned to this, and this y will get assigned to here. Okay, this will be y and this will be x. Got my point? So this is how we can call any function. We can call any function. Got it? Next. Now, one question is here, write a program to print the cube of a given number using method. So to create a method, you should know, like you can create a method only inside the class. So first you will write a class, public class, cube class, okay. And inside this what you are going to write a class that we have written. You can write as directly, you can write a static class, or the last slide that we saw, there is two way like you can use. Like first you can where is that slide? Let me just, okay, so here you see this way also you can approach, or directly you can write the static one. Okay, here you see, like first is a demo test is written. Okay, so first you can write the test part, and then we can write the static part. This is also okay, or directly you can write the static part. Okay, so whatever you like, you can write directly. Okay, so here we are writing it directly. Okay, so here we'll write public static. So what is the use of static? I have already mentioned you. If you write static in the function definition, so whenever you call it, there is no requirement to create an object. If you don't write static, you have to create first object, then use that method. Okay, so public static, and suppose int cube get cube. So I have created the definition, you can see over here, public static int. So this is the access specifier. This is a static keyword we are using. This is the return type, and this is the function name, okay, or the method name. Then in this we are going to write the parameter list. So to find a cube, we need to get one parameter, that is a number, like 2 cube, 3 cube, 4 cube. So for which number you want to find the cube? So here we are going to write int n. Okay, so whatever cube, whatever the number that user will enter, that number will come over here, and in that method, what we are going to do, we are going to first find the answer. So what will be the answer? Int a is equals to, or we can write ans is equals to n into n. Got my point? Then whenever you see int or whenever you see instead of void anything you see, you must write a return keyword. You must write return keyword. So you have to write return, and in this function you have to return one integer value. So what we are going to return? We are going to return this answer. So whenever this function will get called, from this function one integer value will get returned. Okay, so we'll return this ans. So first we'll compute the cube, then after computing whatever the result we got, we'll return it from this function. Okay, so this is the closing of this function and this is the closing of the class. Now suppose you want to call this function outside of this class. Okay, so you can write class test. Okay, so whenever you want to call this, I told you like here is a static keyword written over here, so I don't need to create a method. I don't need to create method because static keyword is present inside the function definition. Okay, so directly what I will tell, I will say sopln suppose you are writing public static void main ps vm and string args. Okay, and inside this main function you want to call this method. How you are going to do? You are going to tell like cube int ans. Here answer is again the local copy of this, and you will say cube class dot, see it is a continuation, cube class dot, or I can write over here is equals to cube class dot, what is the method name? Get cube dot get cube, and inside this get cube we need to pass one number. Suppose we want to find the cube of 3. Okay, so how the control is going, have a look over here. And now we are going to write sopln system.out.println ans. In your exam you need to write it completely, system.out.println. Okay, so how the execution will happen? First control will come to the main method, then it will come to here, and first this will get called cube class dot get class. That means this inside this class this get cube will be called. So that means control from here will come to here. So what we are passing? 3. So in n 3 will get initialized. In n 3 will get initialized. Next it will go inside this, and then answer, a local copy of answer will be created. One local copy of answer will be created for this class, and one local copy of answer will be created for this class. Okay, so here what will be the answer? 3 into 3 into 3, that is 3 into 3 into 3. Okay, 3 3s are 9 into 3 is 27. Got it? So this 27 will be stored in the local copy of this answer, and then we are returning this answer. That means the control will go back to here again. That means in the left part, whatever value in whatever variable we have initialized, this answer that we got will get initialized again back to this local variable. So here also 27 will be initialized. This is a separate class, that is a separate class. We got the result, we returned the result, and the returned result is stored inside another data type. Okay, another variable, and that result is stored in the local copy of this class. And now if you want to print this answer, we'll get 27. Got it? So this is how the function call is happening inside it. Okay, now let us see the next part. So the parameter that appears, so we have actual and formal parameter. So this is very important. This question comes multiple of times. What is the actual parameter, or what is a formal parameter, or what is a actual? Okay, so actual and formal parameter is a very important topic for you all. So focus over here. So you see, whenever you see in the function definition, this is the function definition that you see, this becomes the formal parameter. in the function definition, whatever parameter you see, x and y, here x and y is a formal parameter. And from where you are calling, this is we are calling, and this is a function definition, and from here we are calling this function definition. Okay, so this whatever parameter we are passing over here, this becomes the actual parameter. Actual. Okay, this becomes the actual parameter and this becomes the formal parameter. So you can also tell it as the actual argument or formal argument, or actual parameter or formal parameter. Got it? So you have to keep in mind here in the method definition, whatever parameter is present, that is a formal parameter or formal argument, and whatever we are passing from in the function call, from where we are calling it, that parameter we call it as a actual parameter or a actual argument. Next, argument to a method function. So you can see over here, I have already told you whatever argument we are getting over here, it can be either the primitive data type, that is all the data type that you have learned, integer, double, float, boolean. So all the data type can be a parameter. Apart from that, non primitive, that is the reference type, also can be a parameter of a function. Okay, so here that I am showing you, like what all can be the argument can either be the primitive data type that you already know, int or double or float or anything, and the second part is a reference data type, that is an object, class, or an array. These all also can be a parameter to a function. Okay, next, there is two ways a function is invoked. Like, first one is a call by value and the second one is a call by reference. This is a very important question. This will be asked till your interview, that whenever you will be going for a placement after your engineering, then also this question will be asked. What is call by function? What is call by value and what is call by reference? So first understand this. So call by value means, suppose you are giving something to your friend. Suppose you have your original note and your friend also is asking for that note. Suppose in physics you have made a beautiful note, so your friend is also asking, give me this note. So you will not give your actual copy, you will say, I will give my note, but I will give a Xerox copy of my note. So that means you are giving a Xerox copy of your original note to your friend. That means whatever changes he will do in a separate copy. That means he will not alter your note. That means call by value means you are giving a separate copy to that function. Means you are not giving the actual data to it. Means the actual copy you are not giving. You are giving a separate copy. That means a separate copy is created within that function. Got it? So that means a call by value. Now for the call by reference, call by reference, suppose tomorrow your friend also, and you and both your friends are writing a note in a single document. Suppose your task is given to both of you and you need to write the document in a same copy. So what you will do, you also need to write in the first 5 lines, he need to write in the next 5 lines, so they need to write in the same copy. That means he can also access the actual original copy and you can also access the original copy. So whatever the changes your friend is doing, that changes you are seeing in your copy, and whatever changes you are doing, he is also seeing that changes in his copy. That means call by reference means the actual copy, actual data is getting changed. Got my point? For example, I will show you an example. Suppose there is one function, and in this function, suppose there is variable int x and int y. Got my point? There is one function. Suppose this is a function. I am not writing the function definition, just a simple logic that I am trying to explain you. Suppose this is a function 1 and here is a function 2 written over here. Got my point? So this function gets two value, int a comma int b. So what we are telling what we are telling. So we are telling int. So we are telling b, first we create a temporary variable. We create one temporary variable int temp is equals to a, and we are trying to swap the number. So we are writing temp is equals to a, and in b, we have already copied the value of a. So in a, we are assigning the value of b, and in b, we are assigning the value of temp. So you can see we are trying to swap the number. So whatever the parameter, whatever the value we are getting to this function 1, so suppose we get 3 and suppose we get 4. So in this local copy, we have A, we have B. So after this logic, what is happening? Here it was 3 and here it was 4. After this logic, what will happen? This will become 4 and this will become 5. This will become 4 and this will become 3. Got my point? Now you check, like we are calling function 1 from here, function 1 from here, and we are passing 3 comma 4. Okay, so suppose this is a local copy of A and this is a local copy of B, and here we have 3 and we have 4, so we pass A comma B. So if you see over here, we call the function 1, we are calling the function 1. That means we are passing 3 and 4 to this function, 3 and 4 to this function, and whatever changes is done, this is not affecting this A and B. So this is the change in the local copy, but this local changes is not impacting this changes. That means this 3 and 4, it is getting a separate new copy, and in that new copy, in the Xerox copy, it is making the changes. Got my point? So this is the example of call by value. So in the call by value, this 3 and 4, actual 3 and 4 is not getting changed, but the again a duplicate copy, this is again a duplicate copy, again A and B variable is created inside this method, and in that the changes is happening. But in the actual copy, the changes is not happening. Still the value of A and B is 3 and 4, but inside this method the value of A and B has been changed, has been swapped. That means this is an example of call by value. Here there is another copy, here there is another piece of code, another piece of copy. But if I tell you, like, if you have an object, if you have an object, suppose one class is there, class uh, whatever we can say, like val, and inside this we have int x, we have int y is equals to 3 is equals to 4, and we create this. Now suppose for this class you create one object. What do? You create one object. So if you're calling this, now suppose in the parameter, I told you you can get the parameter as a primitive type or as a reference type. So here, if you are getting a parameter of val type, val is what? Val is a class, and you are getting one object of this class. You are getting one object of this class. Now what I'm telling, I'm calling function 2, I'm calling function 2, and in that function 2, I'm passing val. That means I'm passing one object. So how I can create one object? I will say val v is equals to new val. I created one object. I created one object of that val class. Now I will pass this v. I will pass this v. What I did, I passed that v. So one packet, one object that contains x and that contains y. This packet, original packet, is being passed to this method. Okay. So here also x and y we are getting one original packet we are getting. So here in the original packet, the value of x was 3 and the value of y was 4. Now you focus over here, the value of x was 3 and the value of y was 4. Now here also in the same packet, the value of x is 3 and the value of y is 4. Now you see how we can access x. We can access x using int temp is equals to obj.x. Now what we are doing here, directly we were writing a and b. Now using object dot, we are getting one object. Object is which type? Val type. Val is having two data, two values, that is x and y. So we can access this using, let me make it this as small x, int small x, and this one as int small y. So what is happening? We have one class, we created an object of that class, and in that function too, we are passing that object. So we are getting one object over here. Now what we are writing? We are getting 3 and 4. Now you see, now we are telling obj of x, obj dot x, obj dot x is equals to obj dot y. So what we are telling, whatever the value of x was there, whatever the value in x was there, I'm telling that that y value should come in x. Y value should come in x. Now, in x, 4 will contain. In x, 4 will contain. So what is the current status? Current status of x is 4 and the current status of y is also 4. Now both the value is 4, 4. Now what we'll say? Obj dot y is equals to temp. So in temp, what we had the value? We had the previous value. Previous value of y was 3. So now y will be 3. So we did the changes in the object. Now what is happening? Object works on the actual copy. So if you change in the object, that means in the actual copy also it will get changed. In the actual copy, in the local copy you are changing, still in the actual copy it is also getting changed. That means this is call by reference. If you are making in that copy changes, that means it is also affecting the original copy. So this is what call by reference. Got it? So whenever you deal with object, the actual copy will get affected. Okay, and whenever you work with a primitive data type, that means it will create a local copy, and that will be a call by value. Got my point? Next, I've already mentioned, you can pause the video and have a look. Call by value method copies the value. I told you it will create another copy, create the copies of that value of the actual parameter into the formal parameter. That is, the method creates its own copy of argument and then use it. I told you, whatever value we are passing, it creates a local copy, and inside that local copy, it use the value. Got it? Now, next part is, you can have a look of example of call by value. I've already mentioned you call by value. Just quickly look over here. Like we created int cube, and this cube is a into a into a. It is returning that value. You see over here, inside this, what we are doing, we are passing one side. Side is 7. So side is the local copy of this. Side is the local copy of this method. Okay, and int a, again a local copy will be created of int a, and whatever we are passing, so 7 is getting passed, so in this a it will get 7, and 7 into 7 into 7, whatever the result will be, it will get returned to this. So you see, you pass the side to this, so this value, whatever it got computed, this is not impacting this local copy. So the local copy is like whatever value is returning from here. So we had volume, okay, like vol or side. We had side is 3, right? And then we counted that the value of this cube side. Then we pass this side. So from the here, the control went to this part, and after executing this, the control went back over here. Now, whenever we check the value of VOL, initially VOL was 0, and now after computing it, we got some result, and that result will get stored into this vol. That is, the value of 0 was replaced by the value that we got from the function call, and then when we print out this value, then the updated value will get printed. That means the variable that is declared over here is having a separate copy, and the variable that is declared over here is having a separate copy. That means it is not impacting the actual data. Okay, so it is not impacting the actual data. Got my point? Now let's have a look over here. So write a program to illustrate the call by value method. Okay, so call by value. So we have already seen, you can write on your own, like how call by value works. I have already told you, whenever you use call by that is a primitive data type. Here I showed you. Here I showed you, like just you have to rewrite this. How you will rewrite? You will rewrite it like as we are not returning anything. So we'll write public void swap. That's it. Now you will change function one, wherever we are calling the function one, we'll call swap. Similarly, you write that function definition like this way. So this will be an example of call by value. And if you write the proper function definition, this will be an example of call by reference. So you can write both the logic. You can try it on your own. If not, you can comment it down. Then I will write the complete program, okay, for you. Next, this I already explained. Call by value you can write on your own, okay. Write a program to swap the values. See, this program only I wrote before that. Write a program to swap the value of the two integer through both types of method calling. This program only I wrote over here. So you have to just write the change the function. You have to rewrite the function definition for the call by value. This is the logic. For call by reference, you have to just change the function definition into an actual function definition, and that will create a call by reference. Okay. Okay. So we have covered till here call by value and call by reference. For the remaining topics of this chapter,